Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Budi Setiawan. I'm a doctoral student in population studies at Universitas Gadjah Mada. I would like to present the research about probabilistic projection of total fertility rates for Indonesia and its regions using the Bayesian hierarchical model. Current official population projection for the national and provincial level in Indonesia still use a deterministic approach to prepare the assumption of total fertility rate. There are two scenarios of TFR, namely policy and trend scenarios. In the policy scenario, national TFR is assumed to occur at 2.1 since 2020, while the provincial TFR is kept at 2.1 once it has achieved this point. As for the trend scenario, it uses a logistic function and projects TFR at the national and provincial level as a decline following the TFR data pattern in the past. The UN adopts the Bayesian hierarchical model proposed by Alkema et al. To produce probabilistic projection of TFR for all countries, including Indonesia. Prior scholars have implemented BSM to produce probabilistic projection of TFR at subnational level. Borges initiated the use of this model to project TFR probabilistically at the subnational level in Brazil, followed by Adil and Mazuco that produced the same projection at the same level in Pakistan. Based on national BSM-based projection, Shevchikova, Raftery, and Gerland produced probabilistic projection of subnational TFRs in 47 countries, using three models, namely scale AR1, and one-directional BSM. All of these scholars confirm that BSM is reliable for making probabilistic TFR projection at the subnational level. In line with the studies mentioned above, this research was designed to make probabilistic projection of TFR for Indonesia at the national and provincial level, using BSM-based projection with three prior distribution, namely all countries, Asian countries, and Southeast Asian countries. This research used the TFR estimates for all countries obtained from the WPP 2019 as prior distribution in the BSM-based projection process. For the national and provincial level in Indonesia, the 5-year data were estimated using a logistic function based on actual TFR data collected in the population census and the interchangeable population surveys in different years. This research adopted the BSM proposed by Alkema et al. The BSM had two models, a fertility transition model and a post-transition model. The first model was used to estimate the decline parameters in the second phase of TFR evolution, that is, fertility transition. It's relevant for the national and provincial TFRs in Indonesia, which continue to decrease to replacement level. The decline parameters of TFR, theta C, are estimated with a Bayesian hierarchical model. As for the second model, it was employed to estimate TFR that oscillated around replacement level in the third phase of TFR evolution, namely post-transition low fertility. In the WPP 2019, 40 countries are projected to have entered the third phase, particularly those with fertility below 2.1 live births per woman, and increased fertility rates for at least 2 consecutive 5-year periods after reaching their minima. The parameters ρ and S are estimated with the maximum likelihood estimation based on the experiences of those countries. The two models have been incorporated in the R package called biased TFR. The three BSM-based projections had nearly identical mean average percentage error, which were between 4.05 and 4.17%. It indicates that they can forecast TFR accurately at the provincial level in Indonesia. In terms of precision, the third projection model, with Southeast Asian countries as prior distribution, had the smallest difference between the upper and lower bounds of the prediction interval, namely 0.2 children. For this reason, around 48 and 79% of actual TFR fell within prediction intervals with 80 and 95% confidence level, which were lower than the other two projections. Second projection, with Asian countries as prior distribution, exhibited nearly identical result to the first one, all countries as prior distribution. Both of these projections can calibrate prediction interval so that upwards of 90% of actual TFR can fall within 80 and 95% prediction interval. At the beginning of the projection period, TFR in the official projection was slightly higher than the TFR median of the three projections. Within the projection period, such difference widened owing to the presence of targets in the making of official TFR projection. First, TFR was assumed to hover at 2.1 children during the projection period in the policy scenario. Second, the lower bound of the logistic function was set at 1.96 children so that TFR in the official projection at the end of the projection period was 1.97 children in the trend scenario. However, TFR in the officially projection fell within the 80% prediction interval of two BSM-based projection with all countries and Asian countries as prior distribution, and the 95% prediction interval, the one using Southeast Asian countries as prior distribution. During the projection period, the TFR median in the UN prediction was higher than the one in the tree projection. Such dissimilarity reflects differences in data source and method used to estimate the 5 years average TFR for Indonesia in the 1950 till 2015 period. Meanwhile, the comparable declining pattern between the TFR median values of the UN prediction and the BSM-based projection in this research represents similarity in the projection model, namely BSM. At the beginning of the projection period, TFR in the official projection was higher than the TFR median of the BSM-based projection, except for Kalimantan Tengah, Kalimantan Timur, Sulawesi Selatan, and Maluku Utara. The officially projected TFRs of these 4 provinces were lower than the TFR median in the BSM-based projection. All provinces saw that the officially projected TFRs fell within the 80% prediction interval of 2 BSM-based projection, each with all countries and Asian countries as prior distribution, except for Jakarta and Sulawesi Tengah. Both provinces saw that the TFRs in the official projection fell within the 95% prediction interval. Meanwhile, the BSM-based projection with Southeast Asian countries as prior distribution revealed that the officially predicted TFRs of several provinces were outside the prediction interval. These provinces were Sumatera Utara, Sumatera Selatan, Bengkulu, Kepulauan Riau, Jakarta, Yogyakarta, Jawa Timur, Bali, Nusa Tenggara Barat, Kalimantan Selatan, Sulawesi Tengah, Maluku, Maluku Utara, Papua Barat, and Papua. At the end of the projection period, TFRs in the official projection shifted to the 95% prediction interval of 2 BSM projection, each with all countries and Asian countries as prior distribution. These results were attributable to the different targets set for every province. TFR is capped at 2.1 once it has achieved this point. Sulawesi Tengah was the only province whose officially projected TFR was located outside the prediction interval of the 2 BSM projection. Meanwhile, provinces whose officially projected TFRs were outside the prediction interval of the BSM-based projection with Southeast Asian countries as prior distribution were proven to increase in number. Here the conclusion of this research. Our research supports the use of continent as a prior distribution in BSM-based projection as opposed to all countries to minimize the effect of pattern formed in developed countries on developing ones. Our research asserts that BSM-based projection is reliable for the making of probabilistic TFR forecasting at the national and provincial level in Indonesia. The research implies that the TFR produced in the BSM-based projection is recommended for the making of official population projection that is based on the 2020 population census. These are the references we use in our research. Thank you for your attention. See you on the next occasion. Assalamualaikum warahmatullahi wabarakatuh.